providing electric power efficiently, obligation to serve, is being hosted by the Lungs Energy Institute in collaboration with IMechE Pakistan Power Center. IMechE is a UK-based global organization with a body of over 120,000 members across more than 140 countries. Our mission is to advance engineering excellence, foster innovation, and support professional growth. IMechE Pakistan Power Center continues to play an active role in engaging professionals and students through its centers with a strong emphasis on knowledge sharing. The Lungs Energy Institute has also been at the forefront of research, policy advocacy, and capacity building. With a strong focus on sustainability, innovation, and practical solutions in the key sectors of power, industries, and academia to address Pakistan's pressing energy challenges, shape a roadmap for a cleaner, more efficient future. With this, I'm delighted to invite Dr. Mohammad Munib, who is the chair of IMechE Middle East and Africa and moderator of today's session, to formally commence the proceedings.
Thank you, Aris. Assalamu alaikum and good afternoon, everyone. Am I audible? Can somebody confirm that I'm audible?
Yes, you are.
Thank you. On behalf of Lungs Energy Institute and the Institution of Mechanical Engineers, I welcome you all to today's seminar. As mentioned by Ray, the title is Providing Electric Power Efficiently, Obligations to Serve. We are delighted to host distinguished panelists joining us live from the US and across Pakistan. The seminar is being hosted by Lungs, and we have Dr. Fiaz Ahmed Chaudhry, who's the chairman of Board of Directors, National Grid Company, and senior advisor at Lungs. He will be joining us a bit later. We now move on to have our presentation by Nazur Beg, who is a senior executive of power industry, has a wealth of knowledge working in US and in Pakistan. So we welcome Nazur Beg Saab to start his presentation. What we are going to have is, we will have 45 minutes of presentation by Nazur Beg Saab, and then we will have our panel discussions and Q&A session. Over to you, Nazur Saab.
Assalamu alaikum, and good morning to some, good afternoon to others. I will, before I get into the presentation, just to give you a quick background about myself. I joined the power industry in 1978, and majority of the time I spent in the US, in the utilities. And as Dr. Munib said, I did spend some time in Pakistan, but I think it was almost 10 years in Pakistan, and got to meet a lot of smart, intelligent people. I do understand there are issues within Pakistan which are different, and you have to understand all of that. The reason I went through my background is to make one comment or a message is even if you have years of experience, you never stop learning. Even today, I find new things, and it's a matter of trying to keep an open mind and constantly learning through the process. Okay, having said that, I'll go through the presentation, but before we get into all of the slides, I just want to give you an idea, the genesis of the review that I did. Last year in 2024, when I came to Pakistan again, I come frequently. I heard a lot about overcapacity. Capacity payments are high, tariffs are high, electricity tariffs are high, and IPPs are the problem. And you hear a lot of things in media and from different people. So I decided to look into what is the noise all about? What are the reasons? So, yeah, I started my journey into starting to review a lot of the publicly available data. And based on that, this is the analysis that you would see. Now, I'll also caution or let you know this is one person's analysis, and I believe similar analysis with experts in the industry need to do that independently to understand what's really going on. Then identifying corrective actions or corrective measures with future in mind, what happened in the past and with future in the mind. So because I say the future because of the climate change, because of a lot of renewables coming in and so on and so forth. So you have to balance both of them to move forward. What you will hear, I'll tell you up front what you will hear, what my findings were, or let me put it this way, my opinion based on the data that I saw. Once again, my opinion, one person's opinion. You will hear themes like lack of planning, implementation, lack of implementation or controls, and potential policy issues. Second thing that you would hear is inadequate utilization of assets due to subpar performance, due to numerous issues. Okay, so I'm not going to get into all of them, but there are reasons for why some of these issues come up. Inability to use all the investments to the maximum. When you invest money, you want all of your assets to work optimally and to the maximum utilization so that your capital is not sitting there. To me, if you're using only 50% of the investments that you make, you still have capital sitting. So optimizing all of that. A lot of inefficiencies you will find throughout the sector. You'll hear that. And lack of rigor and controls from the regulatory perspective. One of the things that I am used to is consumer oversight. Okay, so if there are tariffs being adjusted and if capacity is getting added, usually there is consumer oversight, is a body of consumers representing them. So there are a lot of different issues. So having said that, let me get into the presentation. Can you change the slide, please? Okay, briefly, I'll talk about these topics. Okay, I'd say briefly because there's quite a bit, and if the details of a lot of this is in some of the publications And you'll find that under my name, Nazor Beg, on LinkedIn. If you're interested in doing a deeper dive, you can look at it. And if you have questions, you can always ask, and I will try and respond based on the knowledge that I have. But I'll go into load forecasting and planning, capacity, basically licenses issues, dependable capacity versus peak load, generation type of energy use, a little bit on cost of power, transmission and distribution system losses. I've done a little bit of looking into this, but now I'm moving more into the details of what's going on the distribution side. That is not here, but I'll get into that. Okay, I will. Let me just kind of, if somebody doesn't have the screen in front of them, obligation to serve. Okay, this is something that was instilled in me as I was growing up in the power industry. That is, we have an obligation to serve. What does that mean? Okay, we all need air, food, water, shelter, all the necessities in life. Okay, electricity may not fall in the same category, but it is a necessity, not a luxury of life. So all of us in this industry have an obligation to serve the people of this country, okay, or whoever you're serving, which goes beyond making electricity available. It is our obligation to provide reliable and affordable electricity to all. So when people say, or at least when I say obligation to serve, that is what it means. Make it reliable, make it affordable, so that people can rely on, and your industry can work, and people can, have the life that they should have. So can you next slide, please? Okay, load forecasting and planning. I found two studies that were published. IEP, Integrated Energy Plan, which was published in October 2021, and Indicative Generation Capacity Plan, Expansion Plan, IGCEP, in September 2022. Talking to Dr. Fayaz, and I think Univ, you just sent this to me, there's another newer version of the IGCEP that was published this year, and I will do a deeper dive and study that as well. But my comments right now are based on these two reports, one from 2021 and the other one from 2022. Both these reports were a bit late, okay, from this perspective. The capacity buildup began in 2014. Okay, and in both the reports, it basically says that there was lack of adequate data. And, obviously the assumption you use also impact the outcome of your report. So I'm hoping, and I'm told that the new report is far better, and I would expect it to be, because that is something that you keep improving on. The function of load forecasting with real data and appropriate correlation with population and GDP, along with other influences. For example, climate change is a big deal. It does change things. Renewable energy that is coming up, and especially if you look at Pakistan with a lot of rooftop solar, it is impacting the load curve, okay, on a daily basis. So these should be done on a yearly and a continuous basis versus ad hoc studies. Okay, that's really where you refine it and you get better at it. It seems from our perspective, it seems generation licenses were issued with no link or very little weak link to the requirements of the consumers. And I'll show you it in the graph as to what I think went on. So I'll wait for additional comment on that. Also, there's no evidence of competitive bidding process at the time of issuing generation licenses. It's almost like if somebody wants to generate generation license, you could get it. So coordination was lacking from my perspective. Companies that do well in the load forecasting engage in analysis for all consumer classes, use historical trends, economic outlook, historical weather trends, and so on and so forth, and keeping in mind distributed generation projects that might be coming, electrification programs that might be coming. So this disrupts quite a bit of what the requirements might be. And it seems to me that key elements of the process were missing, meaning all the way from forecasting to issuing of the licenses to generation buildup, transmission and distribution buildup. All of that potentially has added about 1.4 trillion rupees per year. Okay, and that shows up again later on. Next slide, please. Looking at the licenses issued over the years, what I found was there were about 65,000 megawatts of licenses issued. And in the graph, it shows, looking at from 1925 to 1965, all the way up to 2030. Okay, this is basically looking at what the GENCOs had, WABDA, nuclear, KE, IPPs shows up big. After obviously 1986 to 1995 to 2026, 2025 timeframe. I put it in decades, pretty much. Of the 65,000 megawatts, about 46,000 megawatt capacity was installed as of 2023, of which 32 or almost 33,000 were by IPPs. So I broke down the IPPs a little bit. 9,500 megawatts is from coal. Capacity factor of 55% was used versus it should be about 85. Again, my opinion. And there's a lot of things go into it. You have the fuel availability, you have transmission, do you have the demand, and a lot of those things are in place or impact this number. By the way, 55% is from 2023, not last year or this year. LNG, 5350 megawatts. The capacity utilization was 75% versus it ought to be 40% based on the cost of fuel. HFO, RFO, 4,700, almost 4,800. It's almost at zero now. You use it when it's needed because of lack of fuel, or they're in load centers and you need it for regulation and so on. Solar has come up and it keeps coming up. Capacity factor of 22 to 25%. Solar is performing. By the way, this is not rooftop. Okay, this is the larger installations. Solar is basically performing as advertised for the region that it's installed. Okay, so I went back and looked at it. It's performing as advertised or designed. Wind, about 28 to 2,900 megawatts. Their capacity factor is less than 30%, and it should be 33 to 35%. Close, but I think there might be some, I don't know this for a fact, but could be because of transmission constraints or congestion. With the addition of K2, K3, nuclear, it comes up quite a bit. Their capacity factor is about 75%. I think they should, they should be base loaded and should be well above 95%. Idle by 2023 is going to add additional, and the total idle capacity could be 20,000 megawatts. So by 2023, there's a potential of very large surplus, again, of 20,000 megawatts total, provided the old generation is not retired. And I know there is more going on since I've did this review. Some of the plants, their PPAs have been terminated, or some are going to retire, and so on. So there's quite a bit going on. I understand that. Next slide. Looking at the capacity buildup. So let's kind of focus on the graph itself. Starting at 2010, by the way, I went back almost 20 years, 2 decades, okay? Looked at it, looked at the data. But right here, it shows from 2010 to 2023. The red bars are installed capacity. The green is available capacity, blue line is peak demand, and the black line is a linear best fit curve, okay, for the peak demand. Over the years, peak demand growth has been about 5%. Okay, and the energy demand is about 3%. So that's basically what it has been. To me, the issue seems to be available capacity, which has been grossly below peak demand. So if you look at 2010 all the way to 2017 or 2018, it is below the peak demand. However, which is the green bar, if you look at the installed capacity, that was only 2,000 megawatt below the peak demand. So it's really, if all of the assets were performing the way they should have been, peak demand would have been met. Yes, you would have had some rolling load shedding, but not as severe as a 12,000 megawatt delta. Okay, that's what I saw. It almost seems like that additional capacity got added just to compensate for it. My opinion, okay, I'm not saying that's exactly what happened, but that's my opinion. Now, you also hear, well, some of these things are because of lack of fuel or whatever. Well, okay, if it is lack of fuel, why would you add additional capacity when you don't have fuel? So it's stuff like that that I look at and I'm saying, okay, I don't quite understand it. People who are part of the process, I'm sure they have valid reasons, but that's not, I don't want to make excuses or accept anything. When I look at consumers and what they're going through, and are we actually serving them, I have to question these things, and that's where I'm coming from. Of the total licenses, okay, here's just an analysis. The total licenses issues, only 68% of the capacity was installed. Fine. That was a blessing in disguise. About 60% of the installed capacity was available for service. Over the five years, 46 to 55% of the capacity has been utilized. So essentially, less than 50% of of the capital invested in generating assets are being utilized with take or pay contracts indexed to US dollars. So that to me is part of the issue or the pain that everybody feels. Next slide, please. Okay, let me switch to generation. So when we talk about generation itself, I said 3% growth of what your energy requirements are. Okay, yeah, peak is higher, but you don't manage peak with base loaded plants. Okay, if you have peaking hours of less than 15% in a year, okay, you don't install base loaded plants. So yeah, peak is getting shaved off now with a lot of solar coming in, but that does not take care of all of the peaking hours. It helps. Okay, I'm not against any form of energy. Climate wise, yes, you have to be careful of what additional assets you bring on or what fuel you use. But you have to look at what's the best solution, and you have to look at the total overall picture, overall energy plan. That's what I mean. Thermal plants utilization was 60 to 65, much higher in previous years. Tidal, nuclear, and renewable sources should be base loaded as long as they are economical. And there is no restrictions or congestion because of transmission. Drop in energy consumption was about 10.5% in fiscal year 22-23, primarily residential and industrial. Residential is 50% of the load, okay, which is pretty high, okay, and you need to bring more industry on, and there's more discussion on that later. Tidal plant utilization should be around 50% or more, if possible. I know there is hydrology issues and so on, but it is pretty low cost once the capital is installed and so on. But if you look at the graph itself, tidal utilization, let's say, I'm going to pick only one year, 2022-23 fiscal year, utilization was 40%. Average cost is 5.86 rupees per kilowatt hour. If you look at thermal, it's at about 30 rupees, and then you have nuclear and so on. They're all listed at. Nuclear plants, their EPP is around 1.5 rupees per kilowatt hour. Should be well above 95%. Okay, why am I separating that? If the capital is already invested, you are going to pay for the CPP. EPP is the additional fuel cost that you would incur that you try and minimize by getting the proper generation mix and having economic dispatch. That's the reason for the economic dispatch. Okay, next slide, please. I took the thermal and drilled down a little bit more as to with the type of fuel. On the graph itself, at the bottom is gas, natural gas. Then you have RLNG, RFO, HSD, and then coal. So plants on natural gas and LNG contributed about 60% of thermal generation. Even with higher costs and shortage of gas, they have higher utilization than cheaper coal plants. Okay. Now, I've also heard this is because of take or pay LNG contracts. Okay, well, to me, I find that's how it was put together, but doesn't mean that they cannot be renegotiated or find a workaround. At least 70% of the generation at thermal plants at the thermal plants is based on imported fuels. Why am I putting that out of and highlighting it? When you have issues with foreign exchange reserves, why are we focusing on importing fuel? Why not give priority to nuclear, tidal, solar, wind, indigenous coal before you even try and import? So later on, if you start looking at electrification and needing additional power potentially, yes, you could use your indigenous fuel, reduce the import of fuel, even for vehicle transportation or any other need. So that gets into the issue of having the overall energy policy or looking at this problem overall. So can you go back, go forward? All right. So I already talked about the coal, potential of using indigenous coal because it's about 12 to 16 rupees per kilowatt hour versus 20 to 25 coal. And by the way, that's gone up in some cases quite a bit because of restrictions and of importing coal fuels and even foreign exchange rates. Okay, next slide, please. All right, how does all of this translate into cost of power? The red bar is EPP, green is CPP, as you can read it. Between 2020 to 2021 fiscal year to 21-22, there's a 44% increase. Majority of it is EPP, which is about 670 billion. Okay. Between 2018 to 2023, CPP component increased 277%, which is almost 1.4 trillion rupees per year. I understand there is renegotiations going on and so on, but that's, to me, minimal impact. Okay, there's a lot of money that's there, but that is the effect of lack of planning, execution, and controls. Okay. During this period, about you guys know how many plants are there, so let me skip to point number 5. CPP components in 2023-24 fiscal year was 14.98 versus 4.5 in 2018-2019. That's almost a 10 rupees per kilowatt increase. So, and then installed capacity, if you go back and look at it, installed capacity in 2018 was about 35,500 with peak demand about 30,000. So potentially some projects could have been delayed or paused until you had the demand. Yes, I know IPPs, people have issues as far as can you do that or not, but was there consideration to look at all of that? I don't have that information, but I think stuff like that need to be looked at for the future, is to be deliberate about what might impact on a decision that might have been made. Can we take corrective action? Can we delay it? And so on. So all of those negotiations could possibly happen. Only my opinion. So anyhow, in 2023-24, cost to CPPAG were 24 rupees, 24 pesos per kilowatt hour, rupees per kilowatt hour. Now, I've just put CPPAG. If you go to the write-up that I did, it talks about K Electric as well, broken that out, which is also, which actually paints a, a picture which is not very good. So let me put it that way. All right, next slide, please. All right. Transmission and distribution. Okay. There are 5 years worth of data that I put here by the various discos, NK Electric and NTDC as well. And transmission and distribution losses are pretty high. Okay. In 6 of the 12 entities, line losses are steadily coming down. Okay. Let me kind of steadily. That's a generous word. I should have used very slowly. They're much higher than where they should be. Okay. I do understand that old age, age of the transmission or distribution system, loading of the circuits, distance of the load centers, all of that impact. But within Pakistan, if you look at the various discos, some are performing better than the others. Even the ones that are performing decent, actually pretty good, I should say, not decent, they're performing pretty good. They are a benchmark for the others to kind of say, okay, what are they doing to fix these problems? So, yeah, you can look outside world, but and to get some ideas, there's nothing wrong with it. But I think there are some examples within Pakistan, and the answer very much could be that these are newer circuits and all the load centers are close by, and whatever the reasons might be. NTDC losses were 2.4%, okay, which is not bad. Could be below 2, but I think my bigger concern would be congestion removal for NTDC for economic dispatch. In the absence of having economic dispatch, you could be spending a lot more money on fuel as part of PLAC, okay, partial load adjustment costs. So, which has been going up as well, okay, which could be because of transmission, which could be because, some of the units are at lower loads or standby because of renewable. So all of these things are coming into picture. If the losses were controlled, this is just pure calculation. Okay, so don't take this as, hey, we can do this tomorrow. If all losses were controlled to 5% over a 5-year period, based on historical consumptions and on historical losses, the savings could exceed 2.2 trillion rupees. This is a 5-year number. These losses, 5 years, if you look at it, are more than all idle plant generation combined in 1 year, fiscal year 22-23. To me, that is a lot. Okay, so it needs focus. Okay, so now we'll talk a little bit. All of this, if you try and take it forward and say, I want to do CTBCM, open market, but yet I got to pay the transmission and distribution company for all of these inefficiencies. To me, it defies logic as to how you're going to succeed. So this part absolutely needs to be looked at and fixed. Next slide, please. Okay, just looking at the opportunities to reduce. Okay, just looking at the graph, and I just did a waterfall chart. Look, starting at about 24 rupees, and which was about 3 trillion rupees for the fiscal year 22-23. 20 PPAs that were negotiated, which is about 85 billion rupees reduction. I have coal and LNG plants, about 170 billion if you basically do the same type of treatment as the rest of the IPPs. Retiring of the old KE or GENCOs, that about another 70 billion, 170 billion. Transmission losses, if you reduce that. Disco losses, which is about 260 billion rupees per year, that knocks it down to about 18.5 rupees per kilowatt hour. Okay. So I just said, okay, if you do that over a year's period of time to control it and setting your targets to do that, you could come down. But if you add additional hydro, which is coming up, inshallah, by 2028, 2029, let's say, even if you say 2030, that would reduce the cost further because of lower cost of generation. And you could actually, this is generation cost, could bring the cost down quite a bit. This is, I'm going to qualify myself here and say, this is literally a theoretical exercise in what is possible, okay, on paper. From there, you go and say, let's look each one of them and can we actually drive this and what is it required to do that? It may require some capital to fix all of these things. I get that. Okay, all of that is there. But this is just to say, is it possible? And can we get there? So this is almost like, should that be my goal? Okay. So with the hydro coming on and with the nuclear, there you could be at about 90% of the energy requirements are through those two, okay, renewables and nuclear. However, I understand this is on paper. Loads are not steady, seasonal variation, daily variations, all of that. So you may not achieve the 90%. You may not have all of the capacity available all the time, but it's a goal to strive for. Next slide, please. Okay, opportunities and recommendations. Obviously, you can come up with quite a few, but I've got just a few here. To me, there needs to be processes in place with proper controls and oversight when there are regulatory changes to ensure waste is removed, managed for the future processes, and that they're made transparent. I believe, yes, IPPs are there, different companies are there, they're investing their monies, all of that is there, bankers are there, they want their debt services and so on. At the end of the day, it is consumers' money. They're paying everybody through their tariffs. So regulators are responsible to make sure that their money is utilized properly and they get the best reliable power and the cheapest power. That's my view. I also believe, I said earlier, independent team of individuals with experience should review and analyze end-to-end process of the power sector. I did this not the best way, but I did that because I'm interested in it. But I think there should be a team that does that, independent of NEPRA or Ministry of Energy or anybody, representing the people to understand what's there and then identify waste and figure out what else needs to be done to fix it. That should be there. With excess capacity, there is a potential that exists for electrification of transportations, cooking, water heaters, and so on. I know it doesn't solve all of the problems, but what this does is offsets other energy costs. If you have EVs that are 80% efficient compared to about 20% of internal combustion engines, you reduce your fuel imports. Same thing with gas, reduce your LNG if you go to electric heaters and so on and so forth, water heaters and so on. So to me, at this point in time, there's an opportunity to exploit the overcapacity that's there and push Pakistan towards greener and more electrification. So all of that, potential exists. Pakistan could, consider green hydrogen for exports, especially with tidal solar. Balochistan has the highest irradiation index, and it's close to sea. Can there be hydrogen exploration, hydrogen electrolysis and so on? Could also consider, I don't have anything against battery storage systems, because I think that may be a solution for regulation of transmission and distribution systems, but could also consider pump storage facilities if you have excess capacity during off-peak hours, and reverse that flow to have power that's available. So number of different things that could be looked at for the future. So one is correct what's there. The team needs to look at in detail as to what should be fixed, identify that, work on that, and then also keeping in mind what the future might bring, and can we get leapfrog into the future quicker because we have excess capacity. Next slide, please. I did a lot, that was a study. Now, this is strictly my opinion, no calculations behind this. Okay, market dynamics and looking at that. Solar PV and net metering, that's going on, and there's a lot of discussion on that, and I will inshallah do some more deep dive into this. It's absolutely positive for climate and the right thing to do. However, the reason for these investments in Pakistan are due to unreliable service and high electricity tariffs with no controls. That's why people are going towards that. Okay, reduces costs for the consumers who can afford it, and it has a pretty decent payback, but it leaves the rest of the people behind. Okay, it's not the total solution, and it potentially increases costs due to PLAC, okay, which is partial load adjustment clause. Competitive trading. The stated purpose is enhance efficiency, increase transparency, and promote competition. Enhance efficiency, I already talked about. If use of system charges are tied to the inefficiencies that are there, how do you make it happen? Okay, so efficiency needs to come up, but I don't think this is going to drive by itself. Yeah, I know there is a discussion, or I've read, I don't know if it's approved yet or not, the cost of 12.55 rupees per kilowatt hour for use of system charges, which, what about the rest of it? And that's only for 800 megawatts. So it's if it's a pilot, fine, but you still have to fix the problems, okay, of your high costs. Increase transparency. It needs to be done, but I don't know how it's going to get administered, so I can't really say if it's going to happen or not. promote competition. It's not possible with one power marketer, okay, and the same inefficiencies in the sector. I don't. I hope I am wrong. Honestly, I hope I'm wrong. But I think these are some of the things that need to be fixed before we get there. The other thing that I notice is artificially increasing natural gas prices, forcing industries to join the grid. Fine, I think I know I've also heard that IMF is forcing them to do that versus driving the costs down and attracting customers because you're providing cleaner, reliable, and affordable energy would help these industries export because their product is based on zero or least cost or least carbon footprint and cost reduction. To me, that's the drive. That's the way it should be going. Not imposing more tariffs or more levies, or I don't believe in that. Okay, so to me, that's going in the wrong direction. And the Pakistan should have an all-encompassing plan, just beyond power sector. As I've said, you got to look at the total energy requirements, everything that you're importing, and what you can produce with indigenous fuels, and especially with renewables and nuclear. So a lot of things that can be done. A lot of opportunities are there, but basically, to me, I think a final comment I'm going to make is this. If the mindset changes, that you have an obligation to serve the general public. And what that means is you got to provide reliable and cheap, inexpensive power to the people. You cannot go wrong. With that, I'll stop. Over to you, Neeb.
Discussion. Our panelists today are from the power sector, and they are as follows. Mr. Amjad Raja, who is the CEO of Thar Energy and Thal Nova, representing Pakistan's power generation, coal, and indigenous resources. We have Syed Fizan Shah, he is Energy Advisor, Ministry of Energy, bringing the policy and regulatory perspective. We have Dr. Masood Ahmed, who is the Senior Executive, Platte River Authority, Colorado, and he's sharing US utility and global best practices experience with us. Before we get on to the panel discussion, we are joined by Dr. Fyaz Chaudhary, who is the Chairman, Board of Directors, National Grid Company, and Senior Advisor, LUMS. I will invite Dr. Fyaz Chaudhary to welcome, to say a few words on this seminar and to the audience. Over to you, Dr. Fyaz.
Assalamu alaikum, everyone. Nazur Saab, it was a very good research. I know you had to rely on the information mainly from the maybe NEPRA website here and there, but your overall conclusions are good. I really thank you for your effort and sharing your research with us. And the one thing which is very alarming for us is somehow we are unable to, as a country, grow our demand. We are 240 million people, and still our growth rate in the winter is about 1%, even less than the our population growth, which doesn't serve any purpose. So the major effort that we need to do in the government and to increase our base load demand. So that should be our primary focus. And the second, this will increase our, sort of percentage utilization of our existing assets. And actually, if there are some fuel mix that we do not like, or maybe not environmental friendly, naturally that can be filled up with the new technology, variable wind and solar, and we can do to the extent that we can replace our fuel with those technologies. But again, the driver would be to increase our sales and reduce peak. And to reduce peak, the only way is demand side management. And from the demand side management, because predominantly our peak is driven by the building load, so it needs efficient. These are the areas where we need to focus, and we need to as a panel we need to discuss those aspects where what the government should do and where we can help as professionals based on the knowledge base. I see very knowledgeable people on the panel on the generation side and on the integrated energy and resource planning. And right, Fazan is sitting in the ministry now looking at things holistically. So I would be rather looking towards the panel discussion, and whatever I don't know, or many other people they do not know, hopefully they will be able to add value, and we are learn from each other. Thank you.
Thank you, Dr. Fiaz Chaudhry. What the panel discussion will entail now, I will just narrate the core challenges, and I will invite the panelists to give their views, very short view, and then we will go on to ask individual questions to the panelists, and that will be followed by a Q&A that will be open to the audience. We will be able to take 2 to 3 questions from people who are present here and those who are joined online. So first of all, the core challenges that Nazul Saab's presentation had highlighted, that we have low available capacity till 2018. We could actually look at fixing that. We have now surplus generation and high tariffs, so that's where we are. We have transmission bottlenecks, and we have distribution efficiencies, resulting in merit order disturbances. So, to me, obligation to serve comes as reliability plus affordability. So I'll ask the panelists to make their statement, very brief statements on the core issues. So first of all, I'll invite Dr. Masood from Platte River.
Thank you, Dr. Sahab, and a very good presentation by Nazur. Sahab was well researched and it seemed like he looked through a lot of data. I've been kind of a student of this industry and also off and on I've been part of the Pakistan power sector. I think planning has not been a bigger issue to me. Execution has been a bigger problem. An institution not coming strongly to stop certain actions. And the original sin that I was saw was 1994 policy. Originally was for 1,200 megawatts, and we ended up getting more than 3,000. So this is the abuse of the policy. We are where we are, where we go from now. So I think the first part, as mentioned by Nazur Saab and Fayyaz also, we need a massive electrification of transportation as well as the heating load. I mean, Pakistan is fuel deficient, so a lot of energy is exported. Last year, fuel bill, my understanding was more than 4 trillion rupees. And so if there is a electrification and heating load in the winter and cooking is electrified, then you will reduce the fuel bill, and yes, you will increase the utilization. It's a common sense approach. So the second thing I would say is there is a lot of solar coming on, which is obviously putting pressure on the revenue of the utilities. In the US, we are looking at net metering 3. Net metering 1 was every kilowatt hour is the same. Net metering 3 is now the revenue paid to the solar owner is truly the short-run marginal cost, which I think runs around 10 rupees or something. So
it's a short one. So I think if we can it's just a short statement. So I think just like we need to move on. I think we got what you alluded to. So we move on to Mr. Faizan Shah.
Yeah, I think, thank you for having me here. I'll just give a little perspective of the ministry, but I think that we can give once we go into the details. For now, I think whatever Nazur Saab highlighted, yes, the problems are there. There are different solutions to it. The government is already working on many of those solutions. My view was that there are some gaps in the presentations of Nazur Saab, which I would like to correct as well. Many things are already running out, but let me make one very important comment. Whenever we see things in the hindsight, they always look ugly, more or less. So let's go back to 2014, and then we consider what was the situation at that time. So we had a lot of load sheddings, and CPEC was coming in, and it was promised to Pakistan that the energy shortage, once it's overcome, the SEZs will be kicking in, 9 SEZs. Unfortunately, the first promise was more or less fulfilled, which was a 10,000 megawatt, or what we say now is an overcapacity. That was fulfilled. The planning part, whether it was the fuel selection was right or not, that is debatable. But 10,000 megawatt came in. And then, unfortunately, we all know what happened in 2018, the political scenarios. And then the CPEC started to roll back. Those 9 SEZs never came, even till date. Had those 9 SEZs came online by, I think, 2018 or between 2018 to 2020, we would probably be thinking of that energy shortage, or maybe we need more energy. So in the hindsight, things look this way, but we also have to see what the government was thinking at that time. And it was less than a miracle, I guess, that within 3 to 5 years, 10,000 megawatt was added. But yes, I agree that which fuel was added, that is debatable. So I'll just pause for now and maybe leave my comments for later on.
Thank you. We move on to Mr. Amjad Raja for his comments.
Thank you very much, everyone, and thanks, Dr. Saab, for having me on this forum. I think very intelligent people, very experienced people have already made a lot of comments, and I, of course, agree with most of it. I just want to add a couple of things. Holistically, if I look at what I even understood from Nazur's presentation as well, as far as energy price is concerned, that isn't a bigger issue because we have reasonably good energy mix. We have nuclear, we have hydros, we have some solar and some indigenous resources, coal as well. I think it's more to do with the capacity payments, and of course that relates to the availability of capital in Pakistan's high risk market, the cost of borrowing is extremely high, and that, of course, at the end of a day, investor also needs a higher returns. But going forward, I think, as Fizan said, historically, whatever has happened has happened. So in going forward, if we can only focus on indigenous resources and try to make sure that we don't spend any more penny into the generation till the time we have already fixed our transmission network and we have utilized the existing capacity. And I also want to highlight one more thing, which I think Nazur also mentioned. Renegotiating the agreements is has to be, rethink, because it has a certain repercussions, because you tend to shatter confidence of investors. Whatever as a country we have committed, we need to fulfill that commitment. We need to find, out of box solutions to make sure we get a affordable price for the customers. Thank you.
Thank you, Mr. Amjad Raja. And we move on to specific questions. And let me start off with Mr. Amjad Raja, because that's what you already had been talking about. And my question is that from generators' perspective, what does obligation to serve means when you face issues like fuel supply, capacity payments, and utilization?
Okay, Dr. Saab, I think as far as we as the generators are concerned, for us, it's mean very simple that we make ourselves available as and when required. And we try to make sure that we produce that electrons within that, the bandwidth which is allowed to us for the voltage and the frequency, to ensure that we do support for the grid stabilization wherever and however we can. And other very important thing is, of course, there is a certain structure, as we have already discussed. If I leave that aside, always the focus is to make sure that the plants are being run in an efficient way, with the minimum operation and maintenance cost, and ensuring a long-term reliability of the asset for the next 30 years, so that we can utilize the useful life and bring the cost down.
Would you like to comment on the limitation that you have in order to transmit your power and limited transmission limitations that you have currently?
Yeah, I think very briefly is a very important, like as you mentioned, I look after the two of the power plants which being operated on the local coal. We mine from the third side, our indigenous resources, but the load factor we are having on these power plants is 65 to 70%. And it is the most cheapest electrons. If I look at the economic merit order, we are at number 3 and 4. Like the most cheapest electrons are not being evacuated because there is a limitation of evacuating electrons from south to the north, because the load center is in the north, generation is in the south, and there's a limitation in the transmission line. We have already, government has put up HVDC line, which is 4,000 megawatt, but maximum it can evacuate is 2,200 megawatt practically. I know on paper maybe it is evacuating 4,000, but what is happening on the ground from last 4 years, it is maximum evacuating 2,002 megawatts. So if, for instance, this can be addressed, then I think in this way we can ensure the most cheapest electrons which is available, can be consumed, and we can bring our cost of, the generation down, and of course give some relief to the customers as well.
Thank you. My next question is for Mr. Fizan Shah. From the ministry side, what reforms are underway to ensure planning, tariffs, and governance, they align with serving consumers better?
Yeah, so it's a short question with a very long answer. So let me just walk you through some of the things which the government or the current ministry, consisting of even Fayaz Saab, we all are working towards. So let me just segregate this into three parts. So the generation, transmission, and the distribution system parts, and then there are some other initiatives as well apart from this. So in the generation side, already GenCos are being disposed of, right? So their employees are being adjusted, they have around 2027 till 2027 when all these generation companies will be completely disposed of. So these are some of the inefficiencies in the generation sides, which we will be pushing back. Then the IGCEP, right? The current version of the IGCEP, me and Fayaz was also the member of the Prime Minister's Solarization Committee, where we agreed that around 7,000 megawatt of power plants, centrally controlled power plants, are not required, and those were taken out of the previous IGCEP in the current IGCEP, and then the distributed. We came to the conclusion that the distributed solar, which will come anyway, so there's no point in adding 7,000 megawatt of centrally controlled power plants. So those were removed, and these distributed generators were added, or their portion was added there in order to keep that. So these are some of the things. Then in terms of captive transitioning, so the government, in order to improve the loading conditions or improve the energy demand of the grid, imposed the gas levy, and due to which 583 captive out of 583 captive, 60% have already transitioned. And you will be surprised that from, as compared to February to August 2024, in February to August 2025, 235% of the energy demand has increased on the grid. That translates into around 800 megawatt of power, which has been added due to this single initiative. Then the government has retired those 5 IPPs. Those were more or less redundant. Those altogether contributed towards around 2,400 megawatt of energy or power demand, right? So these are some of the initiatives. And then IGCEP itself, there was lack of planning. It was not based on the least cost of energy. So Dr. Fayaz, you all know, he has fought a lot, in order to channelize those efforts so that any power plant, whether it is strategic or whether it is candidate or committed, has to go through a certain planning criteria in order to come under the least cost and come into the integrated generation capacity expansion plan. So these are some of this was all backed by the government, the minister, the prime minister, the task force. So all this was happening in the generation side. As when we talk about the transmission side, so there was SCADA 3 project, which is ongoing, right? Then due to all these which we call the congestion issues or the limitation of the power transmission capacity, all these issues. So in the history of Pakistan, first time the IGCEP was linked with the transmission system expansion plan, which we call the integrated system plan. So this was together made in keeping in view each other and submitted to the regulator, right? And previously, what used to happen was that a lot of delay was due to the not national transmission, the distribution dispatch company, for one reason or the other. The government decided to disintegrate this company into 3 parts. So now one will be only the asset management company, and one will be the project management company. So the project. So considering this, hopefully now that the projects which got delayed and due to which a lot of congestion used to happen, that will not happen in the future. So the government is at least trying these efforts. In terms of the distribution sector, a number of reforms have been taken place or are in place. So the government encouraged to establish independent boards without any political influence and people who were on merit. So they selected those, and within 1 year, 193 billion of inefficiencies have been improved. So these inefficiencies were related to the theft and the recovery issues. So you would be surprised that last year, or fiscal year 2025, the recovery rate was 98%. So 98% of the bills were recovered. So now, in going forward, next year, it will only be a matter of stabilization. However, the inefficiency related to the theft or the techno-economic losses, the commercial losses, that still remains. For that, what we're doing, the government is like, I'm heading that program where we're rolling out the smart meter at mass level in all distribution companies. So by end of 2026, all 3-phase consumers must have smart meters. So this is already done. There is a ban on single phase, the conventional meters in the 3-phase. So this is already done. With regards to the single phase consumers, we are looking forward to PPP mode investments so that within the next 3 years, all these will also be smart. All the kind of meters in the single phase consumer category will also be smart. Then we're also discussing the SCADA systems, right? The digitization of the complete power distribution network. So data centers are now being placed in MEPCO, LESCO, and SEPCO. Similarly, the medium-term load forecasting software, which is the bottom-up approach where all these smart meters will be linking into that state-of-the-art medium-term load forecasting. The pilot is being implemented in one of the distribution companies, and then later on it will be rolled out in all other companies. So Dr. Nazur, who mentioned that there is a lack of in the proper forecasting is not being done. So that will be done. Why? Because at the moment, the distributed energy resources are at the consumer level. You know, people are installing solar, people are installing batteries and EVs. You do not have any visibility of what's going on. So once you have smart meters installed at their premises on real-time basis, you would have that visibility, that control on how to. So already at start of this month, the instructions has been passed on. So any net metered consumer who do not have smart meter installed in its premises has to convert to a smart meter within the next 3 months. This instruction has already been passed on. And any over installation of the capacity will be financially curtailed. So if he can install, if he's allowed to install 10 kilowatt, he installs 20 kilowatt, unauthorized 20 kilowatt. The over and above that 10 kilowatt systems, all that energy will be gone wasted. So these are some of the initiatives. We talk about EV. The tariff for EV, the government has reduced it from 74 to 24 rupees. You know, these are all some of the initiatives which the government has already taken. These are already done. So I think it's enough for now, because otherwise I'll just keep on continuing.
Let's give confidence to the participants. But move on to Dr. Masood Ahmed. The question is, in the US, utilities face strict reliability and performance standards. What lessons can Pakistan draw for its distribution companies?
I think the U.S. has 3,000 utilities, the larger and the smaller, and there are some public interest as well, owned by the cities. The company I work for is very localized. So one of the things I think can be localization of the distribution system, where the distribution is given to either the provinces or to the local management. That means then your management, the operation is closer to the ground, and then the monitoring becomes a little easier as well. And couple that with the privatization, partial privatization, maybe management contracts. So you have a very central system, and you have one rate across a very large country. So you have to make the regional rates and give the control of the distribution to the local authorities. To me, that could be one of the possible solutions that can help improve the recovery rate as well as the investments in the distribution system. On the transmission, I think we've talked already. The congestion and evacuation of power is the big problem. Obviously, it's the business case for investing to remove the power from the least cost generation is, if the payback is 1 to 2 years, that should be no brainer, and it should be funded. In the US, most of the transmission, all of the transmission is in private sector. So if a utility can justify the payback is 3-4 years, the regulators and the management kind of support that. So to me, those are the two things on the T&D that can be done. We talked a lot on the generation side. One last thing, I think digitization was mentioned before. If data is made public, we are living in a time where, from the moment a BTU enters the system, its cost, its volume, to the point where electrons leave a house, everything that is possibly can be made public. I think public scrutiny will put the pressure on reducing the leakage as well.
Thank you, Dr. Masood. I come back to Mr. Nazul Beg. Next up, you've analyzed Pakistan system in depth. What is in your view is the single biggest structural gap today?
Well, can you hear me?
Yeah.
Yes.
Okay, all right. Before I respond to that, okay, I do appreciate the comments from everybody. I'm not in any disagreement with anybody at all, because I think everybody comes from their knowledge, their perspective. And a lot of times, as I said earlier, was you always have to keep an open mind and you always learn as to what's going on. I would, and I had the pleasure of having a conversation with Dr. Fayaz a couple of days ago. So he enlightened me with what's going on. So I do appreciate that. And he shared some of the articles which I'm going through. And Anib, you sent me the latest version of IGCP, and I'll review that as well. So anybody else, Fazan, if any comments that you might have, you want to, send them to me. I'd be more than glad to. Same with you, Masood Saab. I know Amjad. I keep talking to him, quite a bit. So not an issue. I'm always learning, and I'm retired. I'm willing to help any way you want me to help you. Okay, that's never been an issue. Now, the question that Munib, and by the way, I know Munib also quite well. So, Rifsab, the question that you asked was one single thing that can be done. Okay, I'm sorry, there is no one single thing. Okay, there's so many of them. It's like, yeah, if you did keep your eyes open, you will trip over them. There's so many laying on the floor. So with having said that, number one thing is, to me, is having an absolutely good, all-encompassing energy plan for Pakistan. Where are you going to go? It takes from what are you importing as far as fuel to how you're going to utilize. So which really gets into how am I going to improve the demand and how do I serve people from one end to another. That is a plan that is required, okay? And in getting into how do you increase the demand? That gets into everything. Fazan basically said things that they're doing. Great, advertise it, right? To me, it is. I'm going to go back to the statement that I made earlier. Is having to do with this. If you are actually working towards driving the cost of electricity for the consumer and making it reliable, you just can't go wrong. Period. Okay, yeah, there will be few things people may not agree with you, maybe coming later. All of that is going to happen no matter what. But if the goal is there that I'm going to drive this, I don't know the numbers, okay, I'm just throwing it out. 40 rupees per kilowatt hour that I'm paying, I'm going to knock it down to 20, and that's my target for, let's say, 2 years down the road, 3 years, 5 years, whatever it is. Advertise it and drive towards it. That to me will make things happen, and people will hold you accountable. Just to say, I'm going to do all of these things, great, please do it. But
Right.
people are not engaged. People want to know, how are you going to make my life easy?
Sure. On that, Nazrul Sahab, you mentioned in your presentation about the possibility of an independent audit. I just would like to get comment from Fizan Sahab. What will be your view on that?
So, so basically, there are two steps, right? So what we're trying to do is we're trying to pull a plug on the generation expansion, unnecessary generation expansion, which I'm sure you sat with Dr. Fiasab, and he probably would have. He's the best person who can explain what he has done and what overall we are trying to do. Number one. Number two, there is a huge inefficiency at the distribution sector level, which we come to know after it has been it has happened, right? So what we're trying to do is we're trying to digitize that so that we know it on actual basis, so that we can pinpoint. So we have like 4 layers of monitoring: one at the consumer, at the transformer level, at the feeder level, and then at the substation level. So all these, what we're trying to do is we're trying to digitize, and then trying to know it on real time basis where the efficiency is. So these are the two things. Apart from that, one Uneep sir, you wanted to say something?
The idea of independent audits?
Yes. So what? So let me try to tell that the Minister Saab has declared this as the year of customer service, right? So right now we're trying to develop the customer service KPIs, the measurable KPIs, right? So there are 2 types of customer. One are the existing customers, one are the customers who will be coming on to the grid in future. So they have different sort of expectations, right? A future customer would have an expectation that his meter gets installed, the very next day. So for that, we will be conducting independent audits as well, because we need a baseline. Based on that baselines, then we will be developing some sort of KPI. So coming back to the other issue, that we want to reduce the cost. So let me just try to be very candid with you. So for example, we have MEPCO. In MEPCO, we have around 7 million consumers. 5 million of consumers are below 200 unit category. That below 200 unit category is already subsidized. So in order to remove the inefficiency, I would need to tell them that, please, I'm not going to subsidize you anymore, right? And you come to pay whatever the other ones are paying, right? So once they do that, so obviously the tariff will go down for the other non-subsidized consumers as well. But it might come to a level where the subsidized category or that poor category will not be able to pay. So these are some of the challenges. It's not something the devil is in the details, right? When you go into the details, you come to know. Like, let me give you another fun fact. Last 3 years, we have a total of around 32 million consumers, right, in the district. The 200 categories in the last 3 years increased from 11 million to around 18 million. So now 6 million to 7 million consumers have entered the subsidized category below the 200 units consumption. And one of the reasons is solarization, right? That is a single phase consumer. That is not the time of use consumer. That is so it's very difficult at the moment. And if you see the subsidy amount which the government is paying to these below 200 lifeline consumers, 200 category units per month consumption consumers, it's increasing yearly basis. So it's quite challenging, but the government is still working. You talk to the industry, the industrial the tariff for the industry has decreased quite a lot, and even the government is still working, thinking out of the box solutions for the surplus capacity. It was initially launched for 3 months, and now the government wants to extend it. So these are some of the challenges, and the government is trying as well. Over to you, Anit.
Thank you, Nanda. I'm mindful of the time, and we had a number of other questions to actually have them discussed, but because of the time available, and we move on now to the audience to take 2 to 3 questions, and I made a request for a short question and a short answer. So first of all, we have it's from our audience. But Kotak Saab has a question. Kotak Saab, can you give the mic to Kotak Saab?
Yes, my question from Mr. Sayyid Fazan Ali, that yes, as you told that regarding the generation, government has taken a lot of initiatives to reduce the cost of generation cost. And also, as you told that there is a plan of the government to add distributed solar system instead of the central solar system. So when you add these distributed solar system, much furthermore, will it affect on the national grid system? Technically, problem will be any problem? If there will be the problem to the national grid, then what will be policy or what step it will be taken?
So, okay, so I'm not sure whether I'm introduced. I'm an electrical engineer as well.
Yeah.
So, and I'm also heading a digitization and decarbonization program, German government funded program in Pakistan. So, that is a very good question. Why we included that 8,000 megawatt? Because even if we had not included it, it would have came online anyway, right? So one of the reasons was to include that it should be visible to everybody, all the policymakers. And now that is the very right question which you're asking. Unfortunately, we do not have any ancillary services regulation as well. So whenever we procure IPP, we tell them, okay, so you are responsible to maintain that ancillary services. And that is one of the very, very important or critical reason that why these congestion happens. And then later on, we have this partial load adjustment charges, and then it is built into the tariff, and then everybody has to pay. So there is no mechanism of procuring the ancillary services regulation in an efficient way. So what we are trying to do at the moment, we're working with NEPRA. So this is my other area where I've engaged foreign experts, and we are working with system operator, market operator, we're working with regulator, and we are now in the process of forming an ancillary services regulation. Right? Currently, there is no mechanism in place that if I want to procure a fast frequency reserves, if I want to procure voltage regulation, if I want voltage regulation up, voltage regulation down service, if I want to procure cold or black start service, there is no mechanism in place at the moment. So then once the ancillary services regulation will be there would be a mechanism. It will give signal to the private sector, and then the private sector will be there to install its different sort of power plants, maybe the battery energy storage systems or the pump hydro or any other ramping up power plants, because with increased solarization or with increased renewable energy, you need these services as well. So it will give a signal to the private sector. So these are just some of the measures which we are already doing, and the government is totally aware of it. Also, the distribution code is being drafted at the moment. It has been drafted by distribution companies, but it is being finalized by the regulator. That we are also reviewing with the help of a lot of foreign experts, and that some changes will also be required in to modernize that. Then there will be IEEE 1547. There is a distributed energy resource regulation or standard, global standard, which needs to kick in as well. So these are some of the measures which are already there, which the government is working on. Over to you.
Thank you. Thank you, Fizan. You wanted to ask a question. Can you introduce yourself and then ask the question, please?
Assalamualaikum. Abdul Shakir here. I'm a student at about 1 year. Thanks for the detailed info, Mr. Noyes. Nazur. I have two questions, suggestions, and I will go by one. And the main question, while listening to your presentation, I got the like main cause burden over the consumer currently is the IPP, the thermal IPP on the thermal part. Second is the transmission losses, and third is the line losses and the feeder cost or non-paying consumers. So if we localize the transmissions, like if I suggest like LANs in the computer network, if we work on the part like so localized transmission in the also in the strategies where the main thermal plants that are adding the cost to 70 PKR in the transmission for the national grid, we can localize separate them from the national grid and make a separate localized transmission, and government can incentivize those regions where only the industries that can absorb the cost of, let's say, 40 PKR per unit of the energy. Government can incentivize those regions, and this can add two parts into the government and the Pakistan ecosystem. One is the foreign investment, and second is the separation of those heavy cost burden plants from the national grid. Second part.
Okay, I think let's have the answer from Nazul sir. Nazul sir, would you like to respond to that?
Yeah, could you very short, quickly, I'm having a problem understanding what was said. If somebody can just tell me what
So
exactly
what
the
he's saying, yeah. So Nazur sir, what he's saying is that we have a lot of thermal generation, right? So why don't we localize those thermal generation and localize the transmission lines and provide that to the industry?
Okay. So I think if you're talking about localizing, if you're looking at provincially or by certain sectors or whatever, when is it possible? Theoretically, it's possible. Okay. However, I think what you need to also take into consideration, where I think Fazan or Dr. Fayaz would have a lot more information on, is that when you're looking at the overall national grid, okay, when you start dissecting these things, you can't just do it blindly. You have to still have coordination. So it has to get to the grid itself. So if you're looking for grid stability in the long run, whether it has to do with voltage or frequency or any kind of disruptions that come about because generators trip, if you isolate it, and if a major generator trips, it is a big jolt on the localized system. If it's not interconnected, it'll take your whole grid down. So these are some of the things that the transmission companies actually do a study on the reverse flow and so on and so forth, right? So theoretically, it makes sense to do that, but I think you have a lot more to gain if you're doing it, especially on the transmission side, if you're doing it at a national level.
Thank
So
you.
if you want, if I can also add 2 points, Oneep sir, if you have time, up to you. Okay, so I'll give you a rule of thumb. Whenever you face any issue in the power sector, think it 3 ways, right? The technical issue, the technical part, the financial, and the regulatory aspect. So like Nazur Saab said, technically it might be okay. Financially, it seems also okay. But what about the policy, whether your policy allows it or not? So you need to see first that whether I can establish a transmission network within the jurisdiction of another transmission company. Right? So this is very important, whether your policy allows or not, number one. Number two, you need to see that that generator is already in contract with the central power purchaser of Pakistan. So whether I can disaggregate him and then directly contact him, this is another thing. So technically or financially, it looks very rosy, but maybe policy-wise, you would have to change the policy, and you need to see. With CTBCM coming in, and with the DNO's rights, which are the distribution companies, the exclusivity is gone. So they have a wire business and they have a supply business. Definitely, you can establish a transmission network in the vicinity, but then you have to see, you need to find your own consumers, which is obviously the industry, number one. And then you will need to see the generator part, whether you can have a direct contract with him while he's having a contract with the central power purchaser. So these are some of the challenges.
Thank you, Fizan sir. I think we are just reaching to the end of today's seminar with one final question from online participants. So, Ramira, do you have any question?
Yeah, thank you. My name is Ramiza Oneem and I am an O-level student entering into A-levels. I have a question which anybody can answer. How do storage solutions like batteries or pumped hydro impact efficiency in power supply?
Zulta.
You're muted, Azur sir.
Zulta, you are being muted.
All right, sorry. I think the question is, how does the battery solution or pump storage impact the generation or the efficiency? Is that correct?
Yeah.
Okay. So I'll give you an example. Obviously, both of them are energy storage schemes. All right. You have to look at how you utilize them. Typically, it's utilized during off-peak hours. Okay, you energize your batteries, or you have pump storage. Water is pumped into pump storage, and it's stored. And it's used for regulation purposes or peak load purposes, and as you reverse the flow and so on. Okay, that's how it's utilized. So you have to have enough capacity during off-peak, and then can you serve the load? Now, is there an efficiency loss? Absolutely. Okay, you absolutely have a loss. The difference being, if you are pumping or saving energy with a low-cost producer, and during peak time, your prices are already high, that reverse flow or the reverse energy that you get is still cheaper than what your peaking power would be. So that's how it's utilized. So you have to look at your needs and what your costs are to go from there. Very quickly, I'll give you an example. We have the company that I used to work for. We had a pump storage of 6 units, 300 megawatts each, and we could store for energy or water for about a week. Okay, it's a very large storage facility. Week meaning not continuous run. The reason for that was to serve peak load. Number two, the area where we had power, large power facilities, our nuclear and our coal, we almost had about 4,500 megawatts in that region. If we lost that signal, these pump storage units would come on and without any disruptions to the network. Okay, so we were using it for multiple reasons. That's where it becomes viable, and it could be part of your overall plan. Sorry, Faizan, you
Thank
had
you.
something to say.
Yeah, I think Nazur sir more or less summed it up. But
Okay.
mainly you need to see what sort of use cases you need. For example, there's the energy arbitrage. Then there is, the need for quickly ramping up or ramping down. That is another use case. Frequency regulation is another use case. Then cold start is another use case. So at the moment, utility scale, you do not need backup requirements as such. So you're not mainly looking for energy arbitrage. You're mostly looking for, for example, with a lot of solar penetration coming in, immediately from 4 p.m. to around 7 p.m., you're quickly ramping up power plants, and battery energy storage system is something which can stabilize or provide support to the overall power system. So this is one use case, and then there are black start, cold start use cases as well. So yeah, this is something how it can bring in efficiencies in the overall power system.
Thank you. It's heartening to note that we have a lot of synergy amongst the stakeholders and appetite to learn from each other. So I think with all of this, connectivity that we have, we can make the best use out of it. And it's also comforting to note that have been a lot of initiatives that have gone in from the government side. Lots being done. So any assistance? I mean, we've got a lot of online resources. We've got connectivity, so you can. Just tap into those resources anytime. I thank Nazur Saab for his valuable time. I thank the panelists who joined us here, Fazan Ali Shah, Mr. Amjad Raja, and Dr. Masood Ahmed. We've reached to the end of the session. I'd like if Dr. Fiaz Chaudhry is there to have the final words from him, please.
Gee, thank you, no, thank you very much for coordinating it well. And slowly, we will actually try to answer all the questions. Primarily, actually, our services to the public, and creating awareness what is the technically or the politically or wherever the government is making some effort, so that everyone is sort of you can say we want to take people along with us, and wherever we need our course correction. That's the intent of these seminars or these workshops, so that we can improve ourselves in our delivery of our professional services. So thank you everyone who have been part of this session as listeners and contributors, and people who ask questions. So that those things are going to make our job a bit better, so that we are well prepared. And the Lum's Energy Institute, is again, on behalf of the Lum's Energy Institute, I thank everyone, especially the panelists, for spending a lot of time, especially in Nazur in their research and sharing their thoughtful ideas as well as recommendations with all the participants. Thank you very, very much.
Thank you, Fiasa. Finally, I think I echo Dr. Fiaz's comments. Lum's Energy Institute, Faisal Ali Khan, for providing this support. So thank you, everyone. So we hope to see you again for the session in a couple of months. Thank you. Take care.
Thank you. Take care.
Thank you. Bye bye.
Thanks a lot.